Okay, we're going to take a look at how to find p-values for the t-distribution. This is chapter 8, section 3. And there's a couple things that we need to find the p-value. The test statistic, and the test statistic, that's the number on the number line. So we're going to need that, and it's going to cut off a tail, and we need to know which tail, which is a function of the inequality that we see in the alternate hypothesis. And then we also need the degrees of freedom, which in this case is one less than the sample size. So taking a look at question 5, let's do the easy things first. So our degrees of freedom here is going to be 13 minus 1. That's going to be 12. Probably what was even easier than that is our test statistic, and that is t equals negative 1.625. The other thing that we need to know is what tail test this is. And that's going to come out of the hypothesis statement, which comes out of the claim. And our claim here is that the mean is going to equal 14 on the nose there. And as we know by now, that the equal case is what ends up in the null hypothesis, which means our alternate hypothesis here is going to be the not equal case. And that means that we are dealing with a two-tail test. Visually, what that looks like. So we have our t-distribution. We're going to have our test statistic out here at negative 1.625. And since it's a two-tail test, not only do we want the area to the left of t equals negative 1.625, we're going to want to double that because we're also going to want the area to the right of t equals positive 1.625. So when we say two tails, we want more than just that one tail that's getting cut off there. And if we take this over to StatDisk, we can go analysis, probability distributions, student t-distribution. And our degrees of freedom was 12. Our t-value was negative 1.625. And then when we hit evaluate, we're going to get 3 probabilities here. So let me take this back over to here. And here's the window that we got in StatDisk. And what we see under our cumulative probabilities here is that we get several different cases. We get left, we get right, we get two-tailed. And this is why we need to know which one that we want. We're in a two-tailed case. We want the two-tailed probability there. So our p-value here is going to be 0.1301. With the t-distribution, we can round it off comparable to the normal distribution, which has been 4 decimal places.